dig into some other stuff. So this is Dr. Bach's thesis group.
Okay, I'm Mary Charles.
I'm Sophie.
I'm Elizabeth.
I'm Lee.
I'm Lydia.
I'm Mary Price.
And this is our senior thesis examining acute cold exposure on cognition and physiology.
So in the past, there was a meta-analysis done by Fallop which explored all the different studies that have looked at cold exposure. And there had only been 10 done with cognition and cold water immersion. And so, in most of those, they decreased the body temperatures of their participants down to hypothermic conditions, which is really cold. And the cognitive domains that they looked at were processing speed, executive function, memory, and attention. And they found that processing speed and executive function were impaired, but then memory and attention had variable results. So within the Fallop paper, there was a study done by Lockhart, which also looked at the same kind of thing, and they found that performance was worse when temperatures were lower. So in these, you can see the numbers on the bottom are the esophageal temperatures, and performances were worse when the temperatures were colder. And then also, it was a correlation, but these did not have group differences because of how differently individuals respond to these hypothermic conditions, which, again, were really cool. So to make ours less, like we didn't want to get our participants hypothermic, and so to make ours more relatable and like everyday life, we had participants do a 3-minute intervention, and so when they arrived, we took some baseline physiological measures, and then the cold water group, so for the arm, like Kai said, they went in up until their elbow, and then in the full body, they went up till their neck. And then for the control group, we wanted to induce stress, but we didn't want to have them in the water, so we had them complete the 2-back task. And so 30 seconds into the intervention, we measured their heart rate and how they felt, and then we did it again at 150 seconds, and then right when they finished the intervention. And then when they got out, they completed the affective measures, and then they did the cognitive tasks, all in the same order for each participant. And Sophie will go into more depth about this.
So we used 3 main physiological measures. To measure heart rate, we used the polar strap, which was secured just below a participant's breastbone, as well as the watch, all of which recorded heart rate. We also used a digital thermometer to take skin temperature, and a subjective feeling task in which participants were asked at various points in time how they felt on a scale of 1 to 100. In terms of our cognitive measures, we focused on 4 main areas of cognition. First, we used the simple digit, which measures processing speed. With the simple digit task, participants were asked to look at this key above and match letters and symbols together. Participants were given 60 seconds to fill out as many trials as possible, and their score was determined on how many correct responses that they indicated. Next, we used the trail-making task to measure executive functioning. This is an example of what it looked like, but basically there was a series of numbers and letters on the screen, and participants were asked to draw lines connecting numbers and their corresponding letters. For example, you'd start at 1 and you'd go 1A, A to 2, 2 to B, and so forth until all the numbers are included in the lines. This was their sample that they did, however the actual test was much longer with more letters and numbers, and scores were based on how fast they completed it and how well they could do it without error. Next, we used go-no-go to measure inhibition. This is an example of what participants kind of saw via instructions. On the computer screen, they were given first a priming task. In that priming task, the computer made a series of beeping noises. Participants were told that if it made 1 beep, they were to click the mouse twice, and if it made 2 beeps, then they were going to click it once. This was used to set up an automatic response so that inhibition could occur. In the inhibition task, participants were still asked at 1 beep to click twice. However, when there were 2 beeps, they were asked not to click. And so their inhibition was measured by how many times they clicked or didn't click during that second no-click task. So real quick, we're going to do a quick demo of what go, no, go is like for some people. So the instructions are when you see the word go on the screen, you're going to clap. And when you see the word don't go on the screen, you're not going to clap. Everyone ready?
Yes.
Very good. Participants were measured on how many correct responses they gave as well as the time it took for them to complete. 5 Finally, we used operation span to measure working memory. Operation span participants are presented with a series of words, and in between each word is a math problem. The math problem has an answer, and participants are asked to indicate if that answer is true or false. So it would be math problem, word, word. And then at the end of all of that, they were asked to record the words that they saw in the order in which they were presented. Words were presented in groups of 3 to 7 words.
So for our hypotheses, we hypothesized that skin temperature would overall decrease after they got out of the tub. So before they got in the tub, we measured theirs, and then after we measured it, and we hypothesized that it would be lower after for both the skin and the arm group. However, for the control group, we hypothesized that it wouldn't change. And then for heart rate, we hypothesized that when they get into the cold tub, that their heart rate would increase and spike, but then 15 minutes prior, it would continue to return back down to normal levels. However, for the skin and arm, we did not hypothesize that there would be any difference. For the how you feel scale, we hypothesized that participants would give us lower levels of enjoyment when they were in the tub, because I don't know about y'all, but I don't like the cold, so especially going outside right now, like it's not enjoyable to be outside, so we hypothesized similarly that they would give us lower levels of enjoyment while they were in the tub. However, for the arm group and the control group, we would not see a difference. And then for cognition, since the tub was only at 59 degrees and only a duration of 3 minutes, we did not know if there would be significant cognition effects, but we hypothesized that due to the cold skin temperature, that could impair cognitive performance. Based on the 4 measurements we used, we thought that there could be a decreasing effect in processing speed, executive function, inhibition, and working memory.
Okay, so a couple important things about our study specifically. We are the first study of its kind to do acute cold water immersion for 3 minutes and at that temperature. Most of the previous research induced hypothermia, so really, really cold water, and they did it for a way longer period of time than we did. Reason we're doing the study, cold plunge is getting increasingly popular among media. I'm sure a lot of you have seen it online. Some of you raised your hands earlier saying that you participated in it yourself. So we were kind of wanting to examine, are the things that are being said about cold plunging true? Do you get any kind of beneficial effects from it? And another thing about our study is that we're the first of its kind to measure working memory. Previous CWI research has claimed to measure working memory, but none of them have used any complex span task like O-span, in which we did use. So now we're going to talk about results. So for heart rate, we contrary to the hypothesis, at times 1 and 2, which was before they got in the tub and 30 seconds in, there was not a spike in heart rate. So we did not see any significant increase in heart rate between the groups at the time of them getting in the tub. However, at times 4 and 5, we find that the tub groups, so for the arm and the full immersion groups, their heart rates were significantly lower than the control groups. As for arm temperature, you can see that before arm temp was around the same for all 3 groups, but after arm temp was significantly lower for the tub groups, so the arm and tub groups had significantly lower arm skin temperatures compared to the control groups. Who would have guessed that cold water would make your skin cold?
Alright, and then for subjective feeling, we see that all 3 groups started out around the same place, but then 30 seconds after their intervention started, we see a significant effect of cold water immersion, where the cold tub group has significantly lower subjective feeling ratings than the other 2 groups, which makes sense because they've just gotten into cold water, so they're not feeling well. But then about 150 seconds in, they've started to adjust to that temperature, and they're going back up in subjective feeling to about the same place. And there you see that difference. For our cognitive measures, we found no significant differences in processing speed measured through symbol digit between the groups. There were also no significant differences for trail making, which measures executive function. And for our go, no-go, we were able to see, if you look on the left here, we can tell that they were clicking for the go trial so that we know they were participating. And on the right right, you can see that they were able to inhibit their responses and there were no group differences there either. And we think that these non-significant results probably just happened because it wasn't a very long period of cold water immersion and it wasn't at a very cold temperature, so it just didn't have effects on these aspects of cognition. But we did find a significant result for working memory measured via OSPAN. As you can see, the cold tub group did significantly worse on this task than the control or arm groups, which is consistent with previous findings showing that there's a relationship between stress and working memory.
So in conclusion, our cold tub temperature aligned with previous research, and we found that the temperature was cold enough to decrease skin temperature. For heart rate, our results were not consistent with previous research in the sense that we did not see an initial spike initially in cold water. However, it was consistent with the fact that it did decrease over time in both cold groups. For how participants felt, it was pretty evident that they were very uncomfortable while in cold water. Their average on the subjective how you feel scale was a 60 out of 100, which is not good. And then for cognition, there's been no previous studies on working memory and cold water immersion. However, there's other studies that show that other stressors decline cognition. For our study, we did not see a significant effect in 3 out of the 4 tests, the cognition measures. However, we did see that working memory was worse after the cold tub. For some limitations, we only had 15 minutes after cold water immersion to test cognition, because after 15 minutes, the body warms up. So there's many different forms of cognition, and we were only able to test 4 different ones throughout that 15-minute period. And we're just not sure how reliable or accurate the tests were in that 15 minutes just because of how fast they were and how the participants only completed them one time. That leads us into our future direction, so we thought maybe adding some other cognitive domains while also focusing on other aspects of working memory other than the ones we focused on. Also, we would like to add a pre- and post-test within subjects design the next time because we only tested cognition after cold water immersion rather than before, and we think that it would be more beneficial to do before and after. And then we also think that it would be interesting to dive deeper in other individual differences such as gender, age, and BMI. And then lastly, we think that decreasing temperature and increasing time in the cold tub would maybe have a different effect or other significant results.
We'd like to take this time to say thank you to our advisors, Dr. Bob and Dr. Hilton, as well as our fellow researchers from Dr. Hilton's group, our research assistant, Isabella Aswood, and all of our participants for participating. And for our token mail. Are there any questions at this time?
What happened to the error bars on the graph?
We knew that question was coming specifically from you.
Well, then you should have answered it before I even asked it.
I'm sorry. I removed the error bars from the line graphs because if you have them on there, they're obscuring the points because they're so close together, so it just looks like one continuous error bar. And so it's not really that helpful, and it just obscures the vision.
So it's all aesthetics.
It
Yeah,
made them look
basically,
ugly, not really fair.
they were very ugly. I'll show you them.
No, it's fine. It's fine.
You said you stopped taking data after 15 minutes because the body temperature is raised. But is it possible that there's some effects that could last longer than the body temperature? Like could the cold plunge have an effect on your brain, your cognitive abilities that last longer than the temperature change of your skin?
There are some like other cognitive measures that have been done in previous studies that have showed like ongoing like lasting things such as attention. However, because we weren't measuring those specific like cognitive things and we were just looking at the ones in research that we were working with now, those did not show anything post 15 minutes. So we decided to focus on the 15 minutes, which had been shown to be the like sweet spot for the cognitive measures that we were doing. However, in future testing, if we were to go a different route and use different cognitive measures, we might extend that time period a little bit just to be able to see the full range of different cognitive aspects.
This is a small detail, but I'm just curious. Usually when you ask someone how you feel, it's on like a scale of 1 to 10. Why did you specifically use like a scale of 1 to 100?
That's kind of a tough question to answer other than just because. But for me, it's easier to rate how I'm feeling on a scale of 100 because it's more or less 1% to 100%. So if I'm feeling 100% right now, I'm the best as I could possibly be, but if I'm feeling 50%, then I'm in between. I'm just neutral.
I also think if you have 1 to 100, you can do more specific numbers, like 63, whereas if it was 1 to 10, they wouldn't be like, I have a 6.3 out of 10. But then we can look at like really specific differences there on that number level.
Last one, Dr. Cliff.
I'm going for the secret sauce. So the effects that you saw in terms of O-span, do you think it's because of the cold or do you think because of the stress that is induced from the cold? Don't answer for them.
Well, we only really have previous research to show us that like there's an effect of stress on O-span specifically,
Right.
but it could be because of the cold, but other studies haven't really been able to do a test that accurately measures working memory. So we don't really know if that's gonna show a specific.
Our measure of working memory was like by far our most exploratory analysis with this, just because there was so like little previous research to go off of. So because of like it being kind of the first of its kind, it's kind of hard to like pinpoint the exact reason without doing a specific study just focusing on cold exposure and working memory.
All right. Well done, y'all.